Today is the 10th.
You're starting with factoring.
I'm starting with factoring. Okay. So I need to open this because every now and then I have a student, oh, I forgot that, and I gave them the handout, so I no longer have a handout. So which one we want to start from factoring?
Minus 1 over 16.
Okay. Does anyone have, can I borrow from anyone? Again, I guess
The packet.
just the last page or the, yeah. Just the last page. And just, can I take it and then I'll disable it so you have your, I'll disable it again. Sorry about that. Okay, so. Okay, every time I'm asked to factor a polynomial, this is what goes through my mind. First, I'm asking myself, is the polynomial in descending order? If not, I'll rearrange it. Does it have a greatest common factor? All terms in the polynomial, do they have a common factor? I pull it out if they do. Then I'm asking myself, is the leading coefficient negative? Because if the leading coefficient is negative, I will also pull out the negative sign, -1. And then I divvy up everything into 3 categories. Only one can happen. If I get a binomial, then these are not on my mind. There's no point. If I get a trinomial to factor, then these are not on my mind. Only this is. If I'm given 4 terms or more, then this is not on my mind. Just this strategy is. So it depends on what I'm given. So always think in these terms. Always. Okay, so now you said that we start with, of course, I forgot, it was 6x squared. What was it? X squared?
Oh, the one that I called negative 1 over 16 plus x to the 4th.
Very good. Okay, so my first thought is, based on that strategy, based on the last page of the handout, my first thought is this in descending order? It's not in the descending order, therefore I have to rearrange it. So I will rearrange it as x to the 4th minus 1 over 16. The next step is greatest common factor. Do these 2 terms, I should ask you, what is it? And you have to say a binomial. This is a binomial, which means the first possible strategy out of those 3. It's a binomial because it has 2 terms. So do these 2 terms have a common factor? The answer is no. They don't have a common factor. X to the 4th and negative 1 over 16 do not have a common factor. Step number 3, I'm asking myself now, is the leading coefficient negative?
No.
No. So once I establish that, once I establish that, then I'm right here with the binomial. So I'm right here with these 4 special products. Since this is a negative, I can only think of the first and the third. If applicable, it doesn't have to be applicable. No special product has to be applicable. But since it's negative, I'm thinking of the difference of squares or the difference of cubes. There's nothing else. Okay, so I start with the difference of squares. And I'm asking myself, can I find something that I square to get that? Can I find something that I square to get this? Or if the answer is no, then I'm asking myself, can I find something that I cube to get that and something that I cube to get this? So yes, there are situations in which both work. So there are situations in which the difference of 2 quantities could be both a difference of squares and a difference of cubes. But those are rare. So which one will I use now?
Square.
Yes. So what do I square to get x to the 4th? And the answer is, that's it. What do I square to get 1 over 16? Very good. So this is not this situation, it's this situation, correct?
Correct.
But good. So now I have to remember from the first day of classes, we worked on this. This is one of the 3 special products that I refreshed your memory with because they're so common and they appear very frequently. So, however, we did not discuss it this way, we discussed it this way. So you said already it's a difference of squares. And what did we say from the first handout that we looked at on the first day of classes? How do I come up with this? Multiplying which quantities? Let's go back to our first handout.
Multiply the first term.
Say it again.
Multiply the first term. Multiply the first term, that's x
Multiply.
squared, x squared.
Okay, you want me to write it both. Okay, that's fine. But I'm using the special product.
Oh,
So that'd be plus
plus.
Okay.
Well,
Yes.
first term and second term.
Very good. So now the question is this. This is one special product, which is the first one in the list or the second one in the list. This is the sum of squares. Well, it turns out that the sum of squares is not factorable using integers. So there is nothing you can do here. But what about this? Thank you. So how do I factor x squared minus 1/4?
X squared, x minus 1 over 2.
Very good. Is the difference of squares again.
Yes, x plus 1 over
The order is not important. We can write x minus 1/2 and times x plus 1/2. Good. So this is fully factored. And there is nothing else we can do here. Any questions for me, please? Yes, please.
So in writing the final answer, are we correct to write it as x squared plus 1 over 4, inclusive of x plus 1 over half minus x minus
It's
half?
exactly what I boxed in. This is the correct answer. You can present it in any order you want, but we have to have three factors. You can write this one first and this one second. It doesn't matter. Because 2 times 3 times 4 is the same with 4 times 3 times 2, is the same thing with 3 times 2 times 4. So the order is not important. But these are the three factors that I have to show. Good, next question, please. Yes? Any questions, please? Yes.
On the paper, I don't know, I left my paper, I don't know where it is, but I got it here. 1 over 27 minus x cubed.
Good.
Yes.
Very good. Okay, so first question I have here is what type of polynomial is this? Very good. It's a binomial. It has two terms. Awesome. Is it in descending order?
No.
No. Please give me the descending order, the correct order.
Negative x cubed
Very good.
plus 1 over 27.
Awesome. Next question is greatest common factor. Do these two terms have a common factor? No. Is there a negative leading coefficient?
Yes.
I have to pull it up. Now be careful what you give me for the inside parentheses, right? So that it works. And we're not changing the problem. I'm ready when you are.
X squared,
Yes? And?
x squared and 1 over 3.
minus 1 over 27.
Very good. So first of all, negative 1 times x cubed is negative x cubed. Negative 1 times negative 1 over 27 is positive 1 over 27. Perfect. Now I have to analyze back to the last page of the handout, please, in which we have to identify if there is a special product, which one it is. Since this is a difference, I have to look at those two alone, only those two with minus. And I have to identify whether this represents a difference of squares or a difference of cubes. As I mentioned, some situations both work, but those are a little bit more sophisticated. So what is this? Is it a difference of squares or a difference of cubes? Obviously, it's a difference of cubes. So in that case, what do I cube to get this? And what do I cube to get this? Perfect, of course. Of course, 1/3. Awesome. Thank you very much. Now, I have to remember how I factor a difference of cubes. So please pay attention, and then we should choose another example anyway. So please pay attention to what I'm doing, and then you can write. I'll give you time to write. So just watch for a second. This is a factor that has to stay, has nothing to do with the difference of cubes. So one more time, this is the difference of, cubes, which factors into a binomial times a trinomial. The binomial, if I factor the difference, is the difference in between and the sum in the trinomial. If I factor the plus, the positive, the sum of cubes, this is plus and this will be minus. As you notice, I haven't even mentioned anything about the third one. This is always positive. So I already have the binomial. Can anyone dictate the binomial?
X minus 1/3.
That's it. Now here is the trinomial. This squared goes here. This squared goes here. And the middle term is just the product of these two. Without the 2 from a different formula, do not confuse it with that. So this squared is here, this squared is here, and in the middle, the product of those two. Just the bare product. So the first one.
X squared,
The middle one.
1/3 x,
Awesome. And plus?
1/27.
1/3 squared.
1/9.
Indeed. Indeed, because when I multiply 1/9 times negative 1/3, I get negative 1/27. So what do we remember from here then? What should we remember from moving forward? There's a difference of cubes factors into a binomial times a trinomial. The binomial is easy to identify. Why? How do I know the binomial? Very easy, I would say. Whatever cube is this, whatever cube is this, and this is the binomial, x and 1/3, and it has to have the same sign. If I factor the difference, the binomial has the same sign. If I factor the sum, the binomial has the same sign, plus. And this one is always the opposite of this. So once I identify x and 1/3, I square, I multiply these two, and I square. Okay, let's choose one more for the difference of cubes or sum of cubes and move on. Because you may have not seen this, who knows? Yes. Anything else?
3x cubed plus 2x squared minus 27x minus 18.
Very good. Okay, this has nothing to do with what I was expecting you to give me. That's fine. That's fine. Let's do this first, and then we'll come back. Good. So my first question to myself is, what is it? And the answer is, of course, it's not the first category. It's not the second category. It's obviously the fourth category. Awesome. Is it in descending order?
Yes.
Perfect. It's in descending order.
Oh.
Do all 4 terms have a common factor that I have to pull out? No, they don't have anything in common. 3x cubed, 2x squared, 27x and negative 18, or negative 27x and negative 18 have nothing in common. All 4 must have something in common that I can pull out. Otherwise, I can't pull out anything. Good. So now what do I do with 4 terms? It's the only method for 4 terms. What did I write on that? Factoring by grouping. So I'm ready. From the first 2, what do I pull out? What is left? Very good. Do you all agree with 3x plus 2 inside? Yes?
Mhm.
Good. What do I have to have coming out from the other 2? I refuse to look. Of course, if I don't get 3x plus 2, I can continue. But I cannot fabricate it. It has to be there. Okay. So I write it first, because who knows what kind of mistake I come up with, right? And now I look. I need a sign, and I need a factor.
-9.
Do you all agree with negative 9? Negative 9 times 3x is negative 27x. Negative 9 times 2 is negative 18. Correct?
Yes.
Very good. What is the common factor now that I need to pull out?
3x plus 2.
Very good. What is left in parentheses?
X squared minus 9.
Is it done? No. What do I need to do next?
X plus
3x plus 2. And what do I do with x squared minus 9? I cannot take the square root unless it's an equation. It's like I have $9 in my pocket. Let me take the square root. Will I have 3? No, I cannot square or take square roots unless I solve an equation. This is not an equation. We are only factoring.
This is x minus 3, x plus 3.
Awesome. So this is the complete factored form of what you just gave me. Okay, I still would like to go back and choose a problem from, I'm looking here, either x cubed plus 8, or I can make one up. Okay, I'm making one up. So, yes, please.
From the previous example,
Yes.
will it be wrong if I'm doing it initially and look at, for instance, say 3 and 27, there's a common factor there. So I say 3x cubed minus 27x.
You group them differently. Yeah, that's fine. You're gonna get the same answer.
That's what I do.
That's fine. That's fine. So you group the first one with the third, and then you would group the second with the fourth. I chose to group the first two and the last two, but the answer is the same. It may be presented in a different order, but it doesn't matter. You may have it as x plus 3 times x minus 3 times 3x plus 2. It doesn't matter. Yes. So there's more than one way to get to the answer, but the answer is the same. So I group the first two and the last two. You group the first and the third, and second and the fourth. That's perfect.
And the only reason why I did because I was looking at Louis, this is like
Yeah, you worked harder. You worked harder than we did, only because I didn't want to rearrange the terms and do that. Right? I said there's no greatest common factor, because no matter what, we have to say the same thing. There's no greatest common factor, and you worked them differently than we did. It doesn't matter. It's perfect. If you know a different method that you would like to use, always stick with your method, because you understand it better than, yeah. Just compare and see if there is anything new that I show you, and if you like it, use it. If not, that's fine. Okay, so let's say 125x cubed plus 64. So what type of polynomial is this? Good. Is it in descending order?
Yes.
Greatest common factor? Negative leading coefficients? Sum of squares? No. Sum of squares is not even factorable. Sum of cubes?
Yes.
Yes. So then what do I cube to get 125x cubed? 5x indeed. And what do I cube to get 64? Good. So then you will give me the binomial and the trinomial. And what is the sign inside of the binomial?
it's a positive
What is the sign in the middle of the trinomial?
minus.
Very good. And the last one, we don't even discuss it. The last one is always positive. Good. Can anyone tell us the binomial then?
5.
Can anyone give us the first term in the trinomial?
25 x squared
Good.
plus 20x.
It cannot be plus. We already
also
established.
plus 20x,
Very good. And the last one?
16.
Right. Very good. So that's how we factor a sum and the difference of cubes. But you have to practice. Between now and Wednesday, it's not going to come back if we don't practice, right? We're not going to remember it.
What's
Okay.
Wednesday? We have a test.
Yes, we have a test every day. Okay, so anything else?
Yes.
Anything else? Yes, please.
4x.
Yes?
4x to the fourth power minus 64.
Very good. What is it? Descending order?
Yes.
Greatest common factor?
4.
Good. It makes it so much more difficult if you don't pull out the greatest common factor. You may not even be able to factor it if you don't pull out first the greatest common factor. So always, always hope for a greatest common factor because the whole thing will be easier to work with. I'm always hoping for the greatest common factor, and I'm always hoping for a special product because those are easy than the rest. Okay, so what do I have?
X.
X to the 4 minus 16.
Good. So now I'm back to the a difference of what? Squares. So once you say difference of squares, then I'm waiting for two binomials.
X squared plus 4. X squared minus 4.
X squared plus 4 is a sum of squares. You can't do anything to it, but x squared minus 4 is not a sum of squares, but a
Different.
of squares. Very good. Which factors how?
X minus X squared.
Very good. And this is it. Anything else for me? Of course, another student showed up in my previous class who did not have a handout. So I need, if I could borrow for a minute, a handout with factoring, simplifying by factoring. I can, you know what? I can pull it up. I don't need it. I don't need it. I have it here. I do. Okay. Anything else from the factoring document? If you have not finished it for today, you must finish it for Wednesday. Just the ones that I indicated, not all of them. I'll get to it in just 1 second. This document, entitled Simplifying by Factoring. Yep, it's okay. Yes, I wanted it because I gave it to a student in the previous class. So, okay. So I would like you to choose, if you have it, that's fine. I would like you to choose one of these 7 problems. The answers are right here. However, it does not show, the document does not show the steps between the beginning and the final. So I would like you to choose a problem because you'll have to do the other 6. Choose any problem you would like to see. Yes, please.
I would like to go over
Yes.
example number 5. I think.
Yes.
Oh, wait,
So you
no.
want to work on the example?
No, I'm sorry. Number 6.
On the problem or the example?
The problem. 2 times x minus 4 times 2x plus 7 cubed minus x minus 4 squared times 3 times 2x plus 7 squared times 2.
So you're talking about this one?
No, number
You-
6.
This one?
Well, actually, I'm sorry. Can we go over number 5 first? I have questions about both.
Okay, so we want to work on number 5 first. Do you have other questions for me from the factoring document? Other questions from the, yes?
I have a question with the solution that you just gave. How will you know? How will you know that that it's a sum of squares that have to be factored?
Oh, because it's this is a perfect square and this is a perfect square.
Oh, the x squared plus 4.
X squared is a perfect square and 4 is a perfect square.
So you don't need
And if it's a sum, it's not factorable.
okay.
If it's the difference, it is.
Okay. Okay.
Other questions from the factoring document? Can you finish it if you did not finish it already? I still have not, I do have it here as well. I do have, okay. No one asked any questions on something like this, which is the most difficult type. No one asked any questions on the last 3. Does it mean that you did not get to those? Or it means that you know what? Yes,
I asked the last one.
you asked this one.
No, all the way to the bottom. Very, very last one.
Okay, perfect. You did. Did we finish it?
Mm-hmm.
Did we answer? But no, okay, this is what you told me. Look,
Yeah, no, yeah.
That does it, you know. So this was the problem, and this is what you gave me. So we
Oh, I
didn't
forgot
finish.
you did.
We didn't finish the problem.
I'm so sorry.
Okay, so we have to go back. Now, this is one type of problem. Don't erase anything, but I have to start or continue it here. So let's finish it. We haven't finished it. So 3x cubed plus 2x squared minus 27x minus 18 equals 0. What do we have on the left-hand side, please? Can anyone dictate?
Polynomial.
No, no, no. This, we already worked on it. We factored it. You're right. You're right. What I meant, I wasn't clear. It's my fault. I wanted you to give me this that replaces this. Because without factoring, I cannot solve. Oh. Oh. Okay. So this expression is the same with this expression. Do we all agree? Okay. So then I have 3x plus 2, x plus 3, x minus 3 equals? Yes. How many solutions will you give me? Because if I had known from the beginning that this was an equation, I would have asked you from the beginning, what is the degree of this polynomial? Exactly, degree 3 solutions. This is a polynomial degree 3, so I have to get 3 solutions. But the degree of a polynomial is the highest power of a variable. So the highest power of the variable here is 3, which means the polynomial has degree 3, and we have to get 3 solutions. And now I'm waiting for you to give me 3 solutions. And this will be the end of the problem, because it was an equation. Yes, what are they?
3x is equal to 3
Okay, you start from the end. Fine.
minus 3
Yes.
minus 2 or 3.
Very good. Indeed. So I have to set 3x plus 2 equal to 0. I move 2 and divide by 3. I have to set x plus 3 equal to 0. I move 3 to the other side, and I have x minus 3 equals 0, and I get x equals 3. Any questions on these 3 solutions?
Can you explain 2 over 3?
Yes. 3x plus 2 equals 0. I move 2. 3x equals negative 2. I divide both sides by 3.
Gotcha.
Any questions? Any questions? Okay. One last time. Are we okay with the document? Yes, please. Is it from here?
Yeah.
Okay, that's fine.
I think.
6 y squared minus,
Y.
yes? Good. Good. So I'm doing all these problems in the hope that moving forward, we're not going to go back and say, can you show me the factoring again? Because we are spending the time right now. So we will not be able to do this every time we meet. Outside of class, yes, but during class time, I would like to move forward. I'm already 2 weeks behind, it appears. So I'm hoping that we clarify factoring right now and we move forward knowing what factoring is asking us to do. Or it's a very good skill to have. Factoring is a very good skill to have. Okay. So the strategy says this. I have to identify the polynomial, which is a trinomial. It is in descending order. It does not have a greatest common factor, and there is no negative leading coefficient. So if I could borrow that scheme one more time, the trinomial is the most difficult type. Trinomials, fine. Polynomials, good. Trinomials, hard. So after I go through these first few steps, then I'm here, and I always hope for a special product. It's not going to work in this case. How come? This is not a perfect square, and this is negative. It cannot be negative. Okay, so this situation is not applicable here. I'm hoping at least now, since this is not possible, I'm hoping that the leading coefficient is 1. No luck. The leading coefficient is not 1. So this is the most difficult possible situation in which I cannot apply special product. There is nothing else I can do to it. There is no 1. 1 is not the leading coefficient. So this is my last chance, the most difficult situation. Here's what we do in this case. After I ask myself those three questions, descending order, trinomial, no greatest common factor, no negative leading coefficient, and I say no special product, and 1 is not the leading coefficient, here's what I do next. I multiply these two numbers. And the product of these two numbers is -6. This number, which is -1, will be the sum. The product is -6. So, I'm trying to find two numbers whose product is -6 and whose sum is -1. -1 is the sum, and -6 is the product. If I did not have this here, if I had just 1, I would have said the product is -1 and the sum is -1. But because this is not 1, it has to be incorporated together with a free term. So one more time. I'm looking for two numbers whose product is -6 and whose sum is -1. Here's how I think about it. I always start by analyzing the product. And I say, if the product is negative, I'm looking for a positive and a negative, for sure, right? Because the product is negative. And the sum is -1. So please give me two numbers. Both conditions have to be fulfilled at the same time. Two numbers whose product is -6 and whose sum is -1, one of which must be a negative number.
-3 and 2.
-1 plus 0.
Say it again.
-3 and 2.
Yes. -3 and 2. -3 and 2. I heard that. So, yes. Are both conditions fulfilled?
Yes.
Not just one. I know you said yes, but I just want to emphasize. Both conditions have to be fulfilled. Otherwise, it's possible that the polynomial is not factorable. So then, the next step, I replace this term. I replace this term using these two numbers that you just gave me. So I will copy 6y, and then instead of -y, I will write -3y.
But 6y squared.
In a minute. We'll get to that. Just don't forget what you want to say. Plus 2y, and I copy -1, and I copy 0. So don't forget what you want to say. So we did not do anything. No magic happened. We only found two numbers whose product is -6 and whose sum is -1, and we replaced that -y, the middle term, was replaced by -3y plus 2y. There is no change, right? -3y plus 2y is still -1. What did you have in mind? You wanted to say something?
No, that's fine. I thought 6y was 6y squared.
Oh, yes, of course. I'm sorry. Of course. Thank you. Thank you. Sorry about that. Of course it is. Thank you. Okay, so all we did was we replaced -y by these two. Now, if you go back and combine them, you made one step forward and 5 backwards. What am I going to do next? What do you think?
Block off.
Yes, of course, factor by grouping. If that's what you meant, yes.
Yeah.
Factoring by grouping. If that works, I'm fine. Good. What do I factor out from the very first two?
3y.
What is left in parentheses?
2y.
2y
2y.
How can I factor out from two terms and in parentheses have only one left?
No, 2y minus 1.
Awesome.
So it would be 3y.
What do I have to have coming out from the other two before I look? Awesome. Very good. As my grandma used to say, with enough torture, we'll get it done. Yes. No, she was kidding. She was kidding. She was kidding. Okay, now I need a sign and a factor.
Minus 1.
Exactly. Yes, you're right. 1 I should not write, but I just want everyone to see it. Now these two terms, this term and this term, have a common factor. I need to pull it out. Please give it to me and I will write it.
2y minus 1.
And
3y plus 2. Oh, plus 1.
now you will give me two options, please, so we can move on.
2y.
No.
Or you took up by answer?
Yes, you can write it one more time, but I would like the answer because now I think everyone is on board.
Y is half.
Yes, y is half indeed.
And y is minus 1 term.
Good. Do we all agree with these two? Yes, everyone? 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 Okay. So now can we say that the document will be done? What I said, what I emphasized, these ones, these two, two here, one from here, one from here. We already did one from here. So one from here, one from here. Yes, between now and Wednesday?
Mhm.
Yes? Say it again. Please do. Okay, good. So now we chose problem, what problem was it? From the simplification. Was it 5?
I actually, the question I had was, number 5 on the,
Can I
on the
copy?
back page of the exercise.
Yes, let's talk about that. That's what you said, right? Okay, I'm gonna copy it. 5? 2x minus 3 cubed. No, it's to the 4th.
Yeah.
Very good. X squared plus x plus 1. And this is to the 4th power as well. Plus. I know you're talking about math, and I'm happy that math makes you so, yes, but
That's one problem.
it's at the end. I know he's trying to be fun. That's fine. It's at the end of the document that is this one, right here, problem 5. Okay, so let's look at this problem. We are asked to factor it in order to simplify. Ready?
No. I'm still copying.
Okay. In the meantime, I'm going to ask you a quick question. And the question is, how many terms does this expression have?
Too many. I like 8.
There's 1, 2, 3, 4. I see 4. 2.
Okay, let's go back.
2. Shoot.
Let's look at this problem. Ready? One quantity. I saw the cell phone. That's why you can count. Put it away. One quantity plus the second quantity. How many terms does this have? Okay. Let's take a look at this. One quantity plus another quantity plus minus another product minus another product. How many terms? Okay. Good. What about this one? One product minus another, 3. Okay. So, please follow me for this one. Hold on. A quantity plus another quantity, 2 terms. So we see here exactly 2 terms. By the word terms, we mean quantities that are added and subtracted. We do not look at how many factors a term has in it. We only count the number of terms, and we see 2 terms. My next question is, would you agree that the first term is kind of simplified? There is nothing I could do to it. Would you agree? But if I ask you, is this completely cleaned up? You should say no. Why would I have a factor of 4 in the middle and a factor of 2 at the end? I'm going to multiply these 2 and put the factor in front to rearrange correctly, to have it in order. I will copy the first term, which is 5, 2x minus 3 to the 4th, x squared plus x plus 1 to the 4th, and 2x plus 1 plus. And then the second factor, the second term, again, how do I simplify it? I'm looking at the time just to make sure I don't go over 50 minutes with the video. Okay, so how do I rewrite the second one?
X squared.
We just said that we put an 8 in front, right? So,
8
good. And then,
x squared
yes,
plus x plus 1
to the 5th, very good. And the last one,
2x plus
minus 3 to the 3rd. Awesome. Now we are looking, so first at this stage, we completely simplified both. The first term was clear, the second term needed some work. And now we're looking at these two terms, and we have to identify the common factors. It's a different story, different question, right? When we talk about terms, we're talking about quantities that we add and subtract. Now we're talking about factors. What are the common factors in these two terms? Common factors.
x minus 3
Yes, 2x minus 3 indeed is a common factor present in both terms. Awesome. Can anyone give us another factor? Maybe there is another factor. Yes, please.
Is that supposed to be multiplied or that the addition sign after the first
You mean this one? Yeah,
time?
it's positive. Let me see what you mean because it's easier to show me. No, you wrote it correctly. But there's a multiplication symbol here as well. So that's this product continues here. Or you can erase it from here and put it here. And put equal symbol. Okay, thank you. Okay, is there any other factor that I see in both terms?
X squared
plus
X plus 1.
Awesome. I see this in both terms. So that's why I have x squared plus x plus 1. We have not discussed exponents for these factors. We only at this stage identify the common factors. Now I have to talk about exponents. So in this term, this factor has power 4. In this term, this factor has power 3. Which power do I choose? Yes, the smallest of the two. Awesome. Yes, of course. Good. This factor in the first term has power 4. Same factor in the second term has power 5. Which power will I choose? 4. Indeed. Always the smallest of the two. Now, ready? From this term, we took out 3 of the 4 factors to x minus 3, and we took out the entire factor x squared plus x plus 4 plus 1 to the 4th, and we still have this left. So from this entire term, please dictate, and I will write it. What is left?
5
Good.
times 2x minus 3
Yes, because from 4 of them, I took out 3, and there is 1 left over.
times 2x plus 1.
Exactly. And I reached this stage right here. I reached the positive. So let's go back for a moment for everyone to see. So 5 is still left in the problem. From 4 factors, I removed 3 of those, so 1 is still left in the problem. These all 4 are out here, so there's nothing left. But there is a factor of 2x plus 1. Everyone? Yes? No?
Yes.
Maybe? Everyone? Okay, plus. Plus what? 8 indeed. So I had 5 factors, but I removed 4 of those. So there is 1 left over.
X squared plus x.
And from these 3, I removed all 3. So what is left? Exactly.
That's it?
There are things that I cannot answer with another language to his nada. I can, but I'm not going to say it. I will say Fs, and you have to figure out what language is that. Okay, so this is 2x minus 3 to the 3rd, and x squared plus x plus 1 to the 4th. What do I do now? Well, I have a lot of work to do. I have to FOIL these 2, distribute 5, distribute 8 in here, Combine like terms and get an expression. Ready? 2x times 2x. 4x squared times 5.
20x squared.
Do you agree with 20x squared?
Yes.
2x times 1
2x.
times 5.
That's
Negative 3 times 2x
6x.
times 5.
minus 38.
And 5 times 1.
3.
Forgive me. Negative 3 times 1, which is negative 3 times 5, which is negative 15.
I
Plus.
see how that happened. Okay.
Let's do this again. Here it is. 2x times 2x is 4x squared, but I had to distribute 5. 2x times 1, but I had to distribute 5. Negative 3 times 2x, but I had to distribute 5. And negative 3 times 1, but I had to distribute 5. Plus 8x squared plus 8x plus 8. And now I copy the first factor. I cannot do anything to it. I copy the second factor. I cannot do anything to it. And now, can anyone combine those for us?
28x squared.
28x squared, I agree with that. So this is 10 minus 30, which is negative 20. Negative 20 plus 8.
Minus 12.
Very good. And then we have a negative 15 with a positive 8. Is this better?
Nope.
No, because you lost me after that 15 up there.
Where?
All the way
Yeah,
up.
the minus 15, is it negative 15 plus 8?
Negative 3.
Plus 8.
Negative 3 times 1 is negative 3 times 5 is negative 15. Now I'm here plus.
Oh, plus
8x squared
I
plus
see what's
8x plus 8.
happening. I see. Okay.
And then we just combine like terms. Are we okay now?
Yes.
No, please can you pull
Which
down?
part?
Please
Which
can you
part?
pull down the paper?
Which part? When you say no, you have to say what it is so I can address it.
No, I was just asking.
This is excessive.
These kind of questions don't come in the test or exam.
Numbers.
What do you think we're doing? Just for fun?
I don't know.
I feel like this has no real life
This is a math
like
problem.
application.
Okay, other questions here? Yes, please.
So did you just multiply the 2 to the 4 to get the 8 in front of the?
Yes, I have to rearrange that, yes.
So that's
You have to rearrange it, because you cannot have a factor of 4 in the middle, another factor of 2 in the back. So the numbers will always go in front. Yes, any questions? Any questions? Yes, go ahead.
Well, so originally the problem was like, actually, never mind.
Is that clear?
Yeah, actually, no, I'm
I can't have factors in the middle and at the end, especially if they're numbers. I have to put them in front. Numbers always go in front.
okay.
I have to rearrange it because it's difficult to see what's happening, and I may forget some parts of the factor. Who knows what I'm doing? So first, always the idea is simplify as much as you can and clean it up to make it easier for you to see what's happening.
Okay.
I had to rearrange the second term.
Yeah, that makes sense.
Good. Other questions here?
Should the x squared plus x plus 1 to the 4th be in front of the 2x minus 3 to the 3rd? In the answer. Should those two be switched so that it's in order?
But this is x squared and x. So this is in descending order. Oh, you wanted to move these too?
I'm just asking what
No,
that.
because it doesn't matter. It's 2 times 3 is 3 times 2. If you write 2 times 3 or if you write 3 times 2,
Right.
it's the same thing.
Okay.
Secondly, I prefer having a binomial first and then a trinomial.
Okay.
But you cannot do anything to them anyway, because when you if you want to cube this, it's going to take 10 minutes. And if you want to take this to the 4th power, it's going to take 20 minutes. So, but we want them factored. It says factor in order to simplify, and it's already simplified. Yes.
Would you mind going over the next one?
Yeah, let's do one more.
Question, please.
Yes, please.
So from the first stage, the right hand that is factored stays like that till the end of the.
One factor, second factor, third factor, done.
What I'm asking is the one up, so it stays like it remains the same till the end of the solution, because on the left, on the other hand, you brought the like terms together, right? On this side, you brought all the
I
like.
had to. I
Okay.
had to, because this was left from the first term, and this was left from the second term. It's a very good question. Let me explain what you are really asking, and it's a very good question. Remember when we factored here? It's the same procedure. I took this in front, and then this was left from the first term, and this was left from the second term. So these were much smaller quantities, and it was easier to see.
Yeah.
So this was left from the first. Can we turn off those phones? I know we can't live without them. So -9, right? The same thing here. See, this quantity was left from the first term. It's the x squared from the previous example.
Yeah.
And all this was left from the second term, which was the -9 from the other term. But this time we have to expand them. I have to expand all this, distribute 5. I have to distribute 8, because all this changes into this expression.
Okay, after distributing 5 and
So I distributed these using FOIL, and then I distributed 5 directly in one step.
okay.
So 2x times 2x and then times 5. 2x times 1 and then times 5. -3 times 2 times 5. And -3 times 1 times 5. And then plus, this is the -9 from the other situation. So this is -9, but now I have plus 8 times blah, blah, blah. So 8x squared plus 8x plus 8. And then I have to combine these.
Okay.
And they are combined here. So it's the same idea, but in the previous example, I only had x squared and I only had -9. Here I had this minus this or plus this, and I had a lot of more work to do. But it's the same idea. Better?
Yeah.
Okay, other questions? Yes. But being that relaxed and not getting involved, it may not work. Meaning we can do 10 more problems, but you know what I mean. Just get on with it. So which problem are we doing then?
Is the one after it, you said?
The one after? Okay, I have it. So it's number 6. So 2x minus 4. 2x plus 7 to the third minus x minus 4 squared times 3. 2x plus 7 squared times 2. And everything over 2x plus 7 to the fourth. Okay. So how many terms we have at the top, and if they are completely cleaned up?
Two,
Page 1.
actually,
No, Jeff.
I'm sorry, I think that bottom term is to the 6th section, so the 4th.
Oh, it is 6. Thank you very much. I copied 4, but the power is 6. Sorry about that. Thank you. Good. So how many terms we have at the top, and if they are completely cleaned up?
2 and
No, very good. Two terms, and the second one is not completely cleaned up. So then I have 2x minus 4, 2x plus 7 to the third, and you will write minus.
yes,
Minus what?
6.
Good. Very good. And x minus 4 squared, and 2x plus 7 squared, and everything divided by 2x plus 7 to the 6th. Good. So now my question is,